Alright, y'all. Today we're going to learn about irrational numbers again, turning repeating decimals into fractions. So, irrational numbers. I'm going to take repeating decimals and convert them to fractions. So for our first example, let's see how this color pulls up. That's pretty good. Let's do 0.333 repeating, where this bar right here means what part is repeating. So what we're going to do is we're going to let x equal 0.333 repeating. Okay? Now, just like scientific notation, when you multiply something by 10, it moves the decimal one space. So if I multiply both sides of this equation where we said let x equal 0.333 repeating, then if I multiply both sides by 10, I would get 10x is equal to 3.333 repeating. Now, I'm going to take this equation right here and this equation right here, and we're going to subtract them from each other, and something really neat's going to happen. So if I take 10x, which is equal to 3.333 repeating, and I subtract x from it, which is 0.333 repeating, what do you notice? Well, when I subtract these, the repeating decimal part back here cancels each other out. So now all that I'm left with is 3. And on the left side, I have 10x minus x, which is 9x. Now it's got one last step. Got to divide by 9 on both sides. And you get x is equal to 3 over 9. Now you can reduce that down to 1/3. You don't have to, you can if you want to, but it's up to you. 3 over 9 or 1/3, however far you want to go with it. Okay. Let's do another example. Let's do example like this, where I have 0.222 repeating. Okay. We're going to do the same thing that we just did on this first example up here. We're going to do the exact same thing on number 2 here. So we're going to let x equal 0.222 repeating. Okay. Now if I multiply both sides by 10 in order to move this decimal one space, I would get 10x is equal to 2.222. And the reason why we do this is so that whenever we line both of these up, when we line this one up and this one up, whenever we subtract them from each other, we'll have the part after the repeating decimal will line up. They'll match. So when they match, whenever you subtract them, they'll cancel out. So we have 10x, which is equal to 2.222 repeating, and we're going to subtract x away from it, which is 0.222 repeating. Now when we do this, the repeating decimal part back here cancels out, okay, and all I'm left with is 2 minus 0, which is 2. On the left side, I have 10x minus x, which again is 9x. And then we have one last step. It's a one-step equation. All we got to do is divide by 9 on both sides, and we get x is equal to 2 over 9. That's it. That's how you do that one. Okay, let's do another one. Let's do 0.444 repeating. Okay, so we'll do this one the exact same way like we did number 1 and number 2. We're going to let x equal 0.444 repeating. Okay, now I only need to move this decimal one time in order to line all this up. Okay, to make it be the exact same after the decimal on both of them. So if I multiply both sides by 10, I would get 10x is equal to 4.444 repeating. Now let's subtract those two away from each other. We'll have 10x, which is equal to 4.444 repeating. I'm going to subtract x from it, which is 0.444 repeating. And when we do that, the same thing happens again. The part after the repeating decimal cancels out. The only thing I'm left with is 4, and then on the left side I'm left with 9x again. And just like before, we have one-step equation, divide by 9 on both sides, and you get x is equal to 4 over 9. That's how you do that one. Okay, now let's do one that doesn't have the exact same number going all the way across, like 3, 3, 3, 3, 3, 2, 2, 2, 2, 2, or 4, 4, 4, 4, 4. Let's do one like this. Let's say I have one that looks like this. Let's say 0.2424 repeating. So the part that's repeating on this one is the 2, 4. So we're going to do the same thing like we did before. We're going to let x equal 0.2424. Now, if I was to multiply both sides by 10, I would only move the decimal one time. And in doing so, it wouldn't line up everything. What would we get? What would we get? Well, if we did that, we multiplied both sides by 10, what would that look like? Well, it would look like this. 10x equals 2.424 repeating. Now, if I was to subtract those two away from each other, the part after the decimal would not line up perfectly, and you'd get something really funky. And that's not what you want. Okay? So, how about we take this one away, do this all over again. Instead of doing it by 10, let's do it by 100, so that I would move it one more time. Okay? So multiply both sides by 100. Then what would I get? I would get 100x is equal to 24.2424 repeating. Okay? Now, the part after the decimal, now it lines up. So we can take this equation right here and this one right here, and we can subtract them from each other. So we're going to have 100x, which is equal to 24.2424 repeating forever and ever. I'm going to subtract away x, which is 0.2424 repeating forever and ever. And what happens? Well, this part cancels out, and we're left with 24. And on the left side, we're left with 99x. And now it's just a one-step equation from here. All we got to do is divide both sides by 99. We get x is equal to 24 over 99. Now I'm not going to make you reduce it, so that's okay. Just leave it just like that. We can still be friends. Okay? All right. Let's do two more examples, and we'll try to call it Try to call it good. 2 more. Let's say I had another example that looked like this. 0.3232 repeating forever and ever. Okay? We're going to let x equal 0.3232 repeating. Now, just like the one before, I'm going to have to move this not 1 time, but 2 times. Okay? Not once, but twice. So I'm going to multiply both sides by 100. So I'm going to get 100x is equal to 32.3232 repeating. So I have 100x is equal to 32.3232 repeating. And we're going to subtract x away from it, which is 0.3232 repeating. Now, when I do this, everything after my decimal lines up, so they cancel out. Now all that I'm left with is 32 on the right side, and on the left side, I'm left with 99x. Divide by 99 on both sides, and you get x is equal to 32 over 99. Let's do one more. Let's say I have 0.40, no, not 42. Let's do 452. Yeah, that sounds good. Where the 452 is repeating. Okay, well, just like the ones before, we're going to let x equal 0.452 repeating. So this time, I need to move how far? Not once, not twice, but 3 times. So I'm not going to multiply by 10, not going to multiply by 100. I'm going to multiply by 1,000. So I'm going to have 452.452 repeating forever and ever. Now we're going to take both these equations. We're going to subtract them from each other. So we got 1,000x, which is equal to 452.452 repeating. Then we're going to subtract x away from it, which is 0.452452, repeating forever and ever. And what happens? Well, part after the decimal cancels. Exactly what we wanted. So we have 452 left. And then on the left side, we're going to have 999x. We're going to divide both sides by 999 so we can solve for x. And we get x is equal to 452 over 999. That's it. That's all there is to it. If you guys have any questions, feel free to, I don't know, drop a comment somewhere. Hope everything worked out all right. Hope you're staying safe and enjoying your break.